Okay, so for the people who aren't familiar with the lightning talk format, that's pretty simple. You got 5 minutes to project and talk about something that you think might be interesting. You get 5 minutes and 5 minutes only. At the end of the 5 minutes, it doesn't matter if you're interesting, you get stopped. And if you want to talk about it more, there's beer afterwards and there's dinner. So it's okay, we'll tell you.
Okay.
All right, so first up we have zombies on maps.
Yep.
Just let the speakers know when they've got 1 minute left.
All right.
Yeah, that sounds good.
Cool. All right. Hear me? All right. So I'm Saxon, and I'm going to talk a bit about Class 3 Outbreak, which is a game I've been working on in my spare time for the last couple of years with a friend of mine. So I'm the programmer, and he's the artist doing all the work. Is that better? So I'll start with a bit of a demo. So it's a game based on Google Maps, and we allow people to create their own maps wherever they want in the world. So these markers show where people have created maps, and so there's obviously a bunch in the US because a lot of people there. But I'll go over to where we've got some here in Sydney and zoom in. So we've got this map here, which is just in Hyde Park. So if I play that one. Hopefully the Wi-Fi is working well. So it's basically, if I click play, it's basically an RTS, so a real-time strategy game based on Google Maps. Let's turn off the music. So you've got civilians running around, zombies running around attacking the civilians, and you've got a small group of people you can control like this. So if I come up here, put on the shotgun, dispatch a few zombies, so on. So that's a pretty simple game, but anyway, so we've got this editor in here. So if people want to create their own map, they come in here, create their own map. We can type in up there. Oops, don't lose my mouse. So this is obviously where we are now. This building just there, so I could create a map here, but instead of that, here's one I prepared earlier. So this is a map of a different area, but basically the idea is so that the game knows where the walls and things are, you have to use this editor to draw in, red for walls, green for trees, things like that. So you can draw stuff and things like that. But that's essentially it. So we've released this version with the editor back in April, and since then we've had about 4,000 maps created by people. The game itself, we've released versions over the last about 18 months, and it's been played about 2 million times. So I guess the question is, what does this have to do with Python? So the front end is action script, so runs in Flash, but the back end of it is running in Python on App Engine. So that's what it has to do with Python. So I basically started learning Python about a year ago just to do this. So I guess the nice thing about App Engine is it scales automatically. So we've got about 6,000 fans on Facebook and people on our forums and blogs, and so every couple of weeks we put out a new update, and this is an update I put out about a week ago when I put the shotguns in. And our usual average is about 1 request a second, and it peaked to about 2 or 3 requests a second when we put that out for a few days, and so I don't have to worry about scaling or anything like that, which is a big difference. When we first released the first version, it got onto the front page of Dig, back when Dig was still popular, and it crashed our dedicated server, so don't have to worry about that stuff anymore, so that's cool. Back in April, so I guess we made this version with Prince William and Kate Middleton in it. Released it just a couple of days before the wedding. It got featured on Gizmodo and a bunch of other websites, and I think our traffic peaked at about 5 or 6 requests a second. So across a few days there, we got about 45,000 plays of the game, and App Engine charges about $8 for that, so not too much of a worry. So the one sort of tip I have about App Engine is that you should expect failure. So pretty much everything, I should have made that bigger, but pretty much everything does fail sometimes, like whatever you're trying to do. And so, and often writes fail more often than reads, and writes are also slower than reads. So as much as possible, if you've got something to write, push it to a background task. But also adding things to tasks will also sometimes fail. So I tend to use this pattern where when I add something to a task, I put it in a try catch or try accept, and then if for this particular one it's not critical, so I just log a message, and then the user doesn't have to care that it actually failed, and I don't care too much if I lose a little bit of data. And a good example of this just happened yesterday. I'm from Perth. 4-hour flight here. The good thing about, it's kind of annoying that it does fail sometimes, but it's to be realistic, every software fails, and the nice thing about it is when it does fail, Google fixes it. I don't have to sit there fixing it. So as an example, I was on the plane. When I got here, I found out that App Engine had a sort of big data store failure yesterday, and by the time I actually read about it, it was already fixed, so I didn't have to be worrying about it. So yeah, that's it. Thank you.
This is awesome. I've organised the speakers so they know what they're doing. It's great. Next up, we've got End Software Patents Coalition. Excellent. Ooh. I make the funny sounds.
Hi folks, my name's Ben. Thankfully it's that time of day, so I'm not going to tell you about software patents because it's more time to go to the pub. Apart from a couple of things, it's generally considered that they're a bad fit for software, and you guys all do software, so these affect you. About a year and a half ago in July, I'm just a software developer. We were getting heckled by the Irish guy, Kieran O'Riordan, who does a lot of patent work, and I figured it was time to pick this up. So I and a few other Melbourne people started a campaign on software patents, and we've done an online letter and a petition to the federal government. And you guys have probably seen me at some stage or been hassled by me at a conference or something like that. It's actually surprising how, the political process. I'm not an activist or anything by any means, but people are interested in listening to what the masses actually think about this sort of thing. So we can actually affect change here. So I just wanted to tell you about the next thing that we're looking at doing, and this is a coalition modelled on what New Zealand did to get their successful abolition of software patents, or the legislation going up for that. It's a coalition of people, of organisations and projects who are interested in supporting this campaign and being publicly seen to support it. So minimally, all I'm asking for people to do is to let me know that their organisation is happy for me to put up their logo and their name on our website, basically. Because I think all we need is to just make this tide visible of how much we don't like software patents, and we can actually affect some change. And I don't expect it to happen tomorrow or in the next year or two, but it will happen after, long-term work on it. So please come and have a chat to me. That's the website down there, and send me an email if your organisation or project is interested in participating. So it'll only happen with your support. Thanks, guys.
If I can just plug this in, it will work better. Sorry. Why is that not working? Is it up?
Yeah, it's up.
This is not about me.
Yeah. Hi, I'm Cody Lovett. I'm 14 years old and have been programming in Python for about 3 years. So this talk is going to be about pyweek, which is a game programming competition that I've been in twice so far. And yeah, basically you have 1 week, it's called pyweek, and you have 1 week to write a game in Python to do with a topic that is set by you and your competitors. So in pyweek I've made a few mistakes and I've learnt quite a bit as well. And so this is my first pyweek. So basically you're this little blue blob and you've just got to escape this evil prison place thing. And so some of the problems with it was that you had to repeatedly click the arrow keys to move, and so that was kind of annoying. And also when you moved, I made it wait so that it would have a little animation of you moving, and so that meant that when you moved, other objects would just slow down for a while. And so this one's my second one. So this was in February, I think. And so this time I figured out how to use images in Pygame. And so then I made this little guy. And so you basically had to move around to go and save the princess. And so this one, I fixed the repeated key press. And so instead of having to repeatedly click, you just held it down and it moved, which was awesome. And so, although with this one, I learned a lot, which meant that there were a few more errors. And so, basically, whenever you flew, this portal thing started to flicker. And yeah, I also still used weighting for everything, and so it was kind of slow, and also using images meant that things drew over the top and everything was a bit harder. And so the next Pi Week is starts on the 11th September, and I hope to see a lot of you there. Thanks.
Oh, okay. I can introduce. I'm a self-introducing speaker. I'm Paul Leopardi from ANU. I just wanted to talk about what it is that I'm doing currently. So I'm lecturing a subject called matrix computation at ANU at the moment, and I've got a class of about 30 students. 30 students come from a reasonably diverse background. I did a survey, and I think maybe 80% of them are mathematicians or budding mathematicians. They're from third year through to masters. Some of them have very little linear algebra knowledge and very little mathematical knowledge. Some are very oriented towards pure mathematics. Some have no programming knowledge at all. Some are very, very much programming oriented and have backgrounds in multiple different languages. They're all being taught in Python, and they're all being expected to write programs in Python using NumPy and SciPy and Matplotlib. This environment has only really been used once before in an undergraduate course at ANU, and that is in first semester by Linda Stalls. So it's all very new to us. The environment in which we were programming for the last few years has been Scilab. And if you know about Scilab, you know that it's a MATLAB non-clone. It's trying to be like MATLAB enough so that you need to know about MATLAB, but not so much that you can actually use MATLAB syntax when you write in Scilab. So it's a pain. We moved everything from that particular pain to the pain of having everybody trying to understand how to do everything Pythonically and zero-based arrays when all of our textbooks are written for one-based matrices. And including the specific textbook that we're actually using at the moment. So the main challenges that I have are getting people who are non-programmers to think programmatically at all. Secondly, using things like specific programming-oriented concepts such as Hall logic, such as weakest precondition, for loop invariance, those things to analyse algorithms, taking their analysis of algorithms, taking that to a level where they can not only understand what the code should be doing at a computer science level, but understanding what it should be doing at a mathematical level, being able to prove things about it. Getting people to be comfortable about both proofs and programming, getting people to be comfortable about how to approximate things. And what I ideally like is get these people to be comfortable about working in small groups in a situation where in mathematics especially it's all individualistic and very competition oriented. So if anybody could talk to me about any of these topics either during the pub break or dinner, I'd be very appreciative. Thanks very much.
introduce you this time. All right, we've got Dylan talking about Plone 4.1 lighter. No, it says better, faster lighter here. You've got lighter, faster, better there.
Okay.
That's not right.
Sorry, wrong talk. So my company does a lot of Plone stuff, and I was too busy doing the other talks, and I thought, oh, well, there was no other Plone talks on the thing, so I'll do a lightning talk. Unfortunately, I'm using slides from an hour-long presentation. I'm going to try and fit that into 5 minutes. This one here, this is a really complicated way of saying that CMSs are different than lightweight frameworks. They have pros and cons. They're two different things. If someone says to you, Django's a CMS and it does what a CMS is, it doesn't. It's different. Lightweight frameworks are good for doing apps. CMSs are when you're going to manage a lot of content. You want to hand it over to people who don't know how to program. So this is what Plone looks like out of the box. So anyone who's had experience with Plone before, it's changed the way it looks. There's a whole bunch of things that changed. So this is what Plone 4 looks like out of the box. This is where I do a long demo and show all the features. I'm not going to do that. This is a really interesting vendor, looking at all the different vendors. Here's Plone down here. One of the interesting things about it is that it crosses 3 of the different areas, and there's not many in there that actually manage to do 3 different aspects of CMSs in there. You'll notice that some of them that cross many of them are the big vendors that actually have multiple products. Plone is one product. Here's another way of looking at Plone. There's WordPress out there. It's insanely popular, WordPress. But then if you look at the top 10,000 sites, Plone's quite far up there. It is actually very popular, some very big sites. So who are these people? Things like front page of CIA and FBI, that's all Plone. 131500 site that a lot of people might use, that's Plone. We're doing some local government sites, doing things like Victorian ACS, really good for scalability. Intranets, who knows how many intranets are out there. A lot of people use Plone for intranets. We do work with that. Because you can't measure it so easily, it's harder to tell. I don't know why. Yeah, okay, that's good. Yeah. So anyway, the thing behind there is the really, really cool bit I want to talk about, which is a thing called Ploud.net. Now, Ploud.net is a online SaaS service that you can go up and sign up to get a Plone site right now. And in fact, Adam, who gave a demo earlier about Diazo, it's this new theming technology, they include that in there, and his original demo didn't work. About an hour before the talk, he signed up to a Ploud.net. He created a Plone instance. He grabbed a copy of the PyCon website. He uploaded it with a rules file with the Diazo, and he had a themed version of Plone running in about an hour. So Plone does it scale. One of the cool things that's gone on is there's a lot of restructuring underneath. So there's a cool graph, which I don't have, which talks about the code count dropping in Plone, kicking out bits and pieces. They've refactored a lot of things. What they tried to do is go from an old technology to a new technology without changing much on the top. Most of that's done already. But anyway, out of the box performance, if you don't optimize anything, Plone's pretty damn fast now. Security is a big thing around Plone. We do a lot with government stuff. I mentioned CIA and FBI before. You might have heard that they got hacked. They didn't get hacked. The FBI site was actually a WordPress site, not the main site, and the CIA was a denial of service attack. So if you look back at those figures there, that's a little bit of a comparison of vulnerabilities of Plone versus some of the other popular CMSs out there. Makes you reflect a little bit. So that was the Diazo stuff I was talking about before. Lets you make really nice sites very fast and lets you leave the theme intact so that your designer can work on the theme as HTML and CSS, and doesn't mean that you have to take it apart and template it. Some very cool things happening in Plone coming up. There's things like CMSUI and Deco, drag and drop, blocks moving things around. They're pretty cool. Chameleon, which is for speed increases. There's a Plone community. That's a bit about the Plone community, how sprints happen. There's a conference coming up. Yeah, blah, blah, blah. Done. Oh, we're hiring, by the way.
I think I might have to borrow someone's adapter.
Oh, I got to stop doing that. All right, sorry. Now we're going to hear about Python at Weta and in visual effects with Sam. As soon as it's Sarah. It says, it's badly written.
It's my fault.
She didn't write this. It's not her fault.
No, but on the whiteboard, it's probably horrible.
Anyway, Sarah, thank you.
Okay, so I'm a production engineer intern at Weta Digital, who you might know from Lord of the Rings or Avatar or Planet of the Apes recently. And I'm working in the production engineering department, which is the pipeline. So with visual effects, you have so many different layers of the process and just hundreds of people working on it. And our job is to be the duct tape and basically that sums it up. And so one of the things that so I'm actually not 100% sure when I'm allowed to tell you guys about what we do. But I know, so how many people here have used Twisted? Okay, cool. So basically all of our pipeline engineering is in Python. There's a lot of leftover Perl stuff, but since I got there, we just do Python. And so just so I don't know any Perl, so I'm glad. But so one of the things we do with Twisted is event-driven programming. And if you've never used Twisted before, you know that it can be really weird. Or if you have used Twisted before, you know it's really weird sometimes when you get errors. You don't know where to go. You're just whatever. So one of the things that we found really useful is unit testing, and there's this package called Trial, which makes it really easy. So I'm going to show you how to write some unit tests using Trial. So you've got your module, and then unit test, that's all you got to import, and then so bear with me for my presentation style, but this is how it's going to go. Okay, so you can have your setup method, which is standard for unit testing, and with Twisted, you use deferreds, and deferreds basically mean it's a deferred result. So you're going to get it later. So the way you deal with deferreds is you add callbacks to them, and then once the reactor goes and spins and it waits for a result, and then once it gets the result, it fires the callbacks on that result. So when you actually write your test, you have to write them using callbacks. So inside your test, you have your callback, and then you can assert equals or whatever. And then at the end of your test, you have to add the callback to your deferred. So that's all you got to do. But then there's some cool things you can do with Trial. And so say you have your second test and you're not really done writing it, but you know that you're going to want to test it at some point. So you can make it turn into a to-do, or you can go, I'm going to have to scroll down now. You can also say you have, you don't want a test to pass yet, because maybe if your deferred doesn't return, then or that's probably a bad example, but say you have something that if you don't get it or it comes back as none or something, then you're going to skip this test, because otherwise this test will fail, and so you can add that skip test. And lastly, there's just another way to skip test. All right, so that's your introduction to testing Trial, or testing Twisted using Trial, and then you just run it from the command line. So you would just say Trial, and then whatever your module is, or no, Trial and then your test module, and then you get this sort of pretty output, but that is not representative of anything because this test doesn't actually test anything. So but you'd get passes hopefully.
That. Oh, you've got your own. Excellent. Oh, Python and science love. This should be good. Just before you start my timer, I gotta take it. Oh, come on. All right, everyone, whoa! Everyone, be awesome. All right, cool. All right, Python and science love. So firstly, some context. I'm from a company called CCG over in Perth. It's a Centre for Comparative Genomics. And we do genomics analysis, assembly, annotation, alignment, sequencing, metabolomics, protein expression, cell biology. I'm not a biologist, I'm just a computer guy. But an example research area is like wheat ancestry. Like wheat has a huge, long ancestry, and we breed all sorts of different types of wheat, trying to create like a super Frankenstein wheat, right? And this is for the benefit of mankind. And look, there are many more research areas. This is just one tiny little slide. So I'm going really fast because I've got lots of slides. But I'm a programmer. I'm not a biologist. But the challenge is to do with scientists, because in the beginning, scientists, the non-computing type, they're quite unhappy. And the reason is, well, firstly, they do science. And this is important, right? Science is important. Secondly, they can have awesome hair, like this guy. Here's Ada Lovelace's hair evolution. Check her out. She was a program pioneer and paved the way for Star Wars hairstyles. And there's also Moustaches as well. There's the cheeky and the blue steel is Nikola Tesla. I can't say that the last guy is actually a scientist, but he's pushing the boundaries, so I'm going to include him anyway. So the third thing, though, about scientists is they collect data. Holy shit, they collect data. They are freaking experts at collecting data. So why is this panda doing this to this kid? Surprise! It's a freaking scientist, right? So they've got this data collection thing down pat, right? And if you let them, they will just collect massive amounts of data, right? There's lots of fields around that are generating huge amounts of data. Geoscience, astronomy, chemistry, bioinformatics, particle physics, moustache science. Actually, they all do. Like, just anyone that you can think of, there's lots of data in there, right? And so here's another thing we know. Computers. This is not really, I don't even know what that is. The other thing is supercomputers. Never forget about those. So traditionally, see, this is the problem, right? And it was kind of talked about earlier by Mary, that scientists will start a project, a PhD project, and they inevitably find the software that they want to use, that they assumed existed, doesn't exist, or it does exist and it's crap, so they decide to write it themselves. This is a bad move, right? They did their work in chemistry, and we did our work in programming. So you get the worst of both worlds. Their science suffers, and they write terrible software. It causes a lot of grief. The point is that scientists aren't necessarily programmers, and they shouldn't have to be. So meanwhile, there's programmers, right? And here's the solution. So we believe, where I'm from, that rather than a jack of all trades, master of none, you should be the master of your domain. If you're a Seinfeld person, you know what that means. It's not the master of my domain name. It's more like this. I do what you do and do it well. So you let scientists do science, you let programmers do programming, and then we're all rock stars. So at CCG, we have a team of super programmers. We use a lot of Python and a lot of useful tech, Twisted and Memcache and Tokyo Cabinet and all these cool things that you can do with Python. We take huge intricately linked data sets and we make them available to scientists in a very flexible way. So we do a lot of things web-based. We target the web, makes it globally accessible, very flexible in terms of how it's displayed. We have massive display walls that display all this type of data, powered by like 9 projectors. And in terms of Python, we like Django. We bred it with Mako, which is a templating system, and a whole bunch of other customizations, and we made Mango, and we put that on Google Code. And using that power, we can solve problems. So a massive Metabolite Repository that has a large curated list of metabolites. Here they are. There's a whole bunch of stuff, just different stuff that's come off a mass spec machine, and it's all in a whole big searchable database. But what the hell is this? What if you just have something, you don't even know what it is, you've just fed it into a mass spec machine and said, tell me what this is. So we had to have an answer for that. And using Django and Tokyo Cabinet and a whole bunch of NumPy and Python, we worked out how they can identify the mystery compounds. We also built an end-to-end data distributed experimental design system. And this allows them to do experimental design, and then all their mass spec machines sync their data back to their website from wherever they are in Australia. But don't forget the supercomputers. We have XE, which has a whole bunch of cores and disks and flops. And we have EPIC, which has even more. This thing's massive. This is a barrier to entry, though, because
scientists need to talk about moustaches. So what we did was we built Yabby. Yabby allows them to just drag and drop a workflow of tools, run their jobs, and see their results. They don't have to do any programming at all. Problem solved. Scientists get their stuff done. They're happy. They're in love. Thanks, Python. And I'm done. Let's hope this works. Yes, Mom. Oh, there we go. Cool. Okay, so I'm going to be talking about philosophy and other related things. So this guy here, his name's Bobby McFerrin. He sung a song in the 80s called Don't Worry, Be Happy. I think that's a pretty good philosophy. That's the end of my talk. No, it's not. A couple of months ago, a friend of mine alerted me to the existence of one of his albums on Twitter. And as a standard computer geek, when I find something interesting, I go straight to Wikipedia and browse things for about half an hour. And there he is. He's very easy to find. I just went to his Wikipedia page. And I started clicking around for about 10 minutes, and then this happened. Wikipedia stopped working. And my entire life was upside down in an instant. This is absolutely a true story. It happened in May. And you can tell this is a true story because 2 days later, some other nerd published a webcomic. And yeah, I thought this webcomic was good, and there was a tooltip on it which said, if you follow the first useful link in a Wikipedia article, you'll eventually come across the article on philosophy. And I thought, this is interesting. Really? So I pondered the bottle of mineral water on my desk, and I thought, that's going to have a Wikipedia page, isn't it? So I went to that, and I followed the first link, which says brand, and I followed that. I went to identity, and I got there in 4 links, and this completely and utterly astonished me. Really, is this? And so I figured it would be a good idea to investigate this. How would I go about doing this? Well, I could have done a massive amount of manual data entry, or I could code myself some Python. And so I got confused by trying to figure out how to get all the data out of Wikipedia, until I discovered that Wikimedia's maintenance code and their bot for putting in stub articles and such like that is all written in Python. And they have this program called Wikipedia bot, which is a bot for getting stuff out of Wikipedia. And there's another Python library called mwlib, which can pass wiki markup from Wikimedia wikis. So basically, I came up with a solution, which would be to download a page, find all the appropriate links, follow the first one, and repeat this, and then produce a graph. Now, I understand that some of you have a computer science background, so this is just depth first search. You should be able to recognize it. So I started with a list of completely unrelated articles. And I output my graph in a format called .dot, which basically you give it this sort of data and it produces a graph that looks like that. And there are tools out there which can take the .dot data and make a graph out of it. I use one called GraphViz. And that article gave us something that looked like that. As you can see, it's kind of a tree. It starts at the top, and at the bottom, there is our philosophy article. But there are other clustering points. This one on science is apparently very important, and at the top there's this concept of a state or a nation or something like that. So I decided to start off with a list of 2,300 start pages. I accidentally downloaded 2.43 gigs worth of text. That was a bit of a mistake. And I ended up with that graph. And you can see everything that is happening, can't you? There's our article on state, and there's philosophy down there, and there's where my code broke up in the corner. That tree's really hard to read. There's another program that comes with GraphViz called Neato, which allows you to do something called force-reduced graphs, which basically makes subgraphs of a graph cluster around clustering points, and you get something that looks like that. And there's our state, and there's our philosophy. And so I basically decided I'd graph it and keep on adding more and more points And so that's what Wikipedia looks like, guys. And that's with about all 2,300 links put in. So thank you.
Hi, my name's Caleb. Caleb Ufton. I'm from the Sunshine Coast, originally from New Zealand. Please don't hold it against me. I'm working at Optus, which is like Telecom back in New Zealand, who I worked for a little under 2 years doing multi-million-dollar projects there, which is really cool, rolling out ADSL to all of our local town folk way out in the WAPs. Optus is way, way bigger. Far more bureaucratic, which means being someone on the phone dealing with customers who thinks like a programmer is extremely painful. I've been there for a little over a year and a half and decided that there's a lot of stuff that can be automated. So I did the really foolish thing and talked to my teammates and said, what's something you hate doing, and I'll try and automate it. So they have this process called a CIR, which is a customer information report. So they get a PDF document, which is where data goes to die, not my quote, someone else's. And it's from a in-house tool, so why they can't use something useful like XML or Word or even just text, I don't know. But anyway, it's got tooltips which they're allowed to show to the customer, and there's lots of information in there that they're not allowed to show to the customer. So they manually go through this PDF document and cut and paste. Right? So, and there's about 7 different customers that for priority 1s they have to do, priority 2s if it's requested they have to do it. And it's things like customer names, customer contacts, phone numbers. They're not allowed to show these. There's a specific job type which most of the time is sanitized. So I went, well, can't you just copy that and use that? And they said, well, yes, if it's been done properly, if the users have followed the procedure, which anyone here that's programmed for more than 10 minutes knows isn't the case, then yes, you can do that. So I set myself this task, and so far I've got a PDF document with lots of fun information that unfortunately I can't share, hence not having my laptop up here. I've used PDF to HTML.exe because I'm running in Windows for some strange reason, and subprocess, which may or may not be the best way to do it, to convert it to a complex XML file, which gives me wonderful markup with a whole bunch of location variables, so I can do top, a range lookup for all of the text attributes, sorry, all of the text items that have an attribute of top being 0 to 140, I decided, which grabs the header. So I can then ignore that when I'm searching because I know it's going to be the same on every page. Where I'm stuck at now is fudgy, which is also kind of fuzzy logic, which is something I've seen in other people that do scraping. So basically what I'm doing is scraping, and there's a lot of people out there I know that work with scraping stuff. So if anyone has experience with scraping information from really horrible sources, I will hunt you down, or you can hunt me down, please, and I'll buy you a drink because you have a nice beard. No. So I also have this really warped ambition of, once I've got a pile of text stored somewhere in memory to manipulate, I would like to use, and this is how you know haven't had my soul crushed yet, I want to use the natural language processing toolkit to summarize the information and actually then generate a document. Shoot for the stars, fall somewhere, hopefully not in a pile of poo. This is how I do projects. So yes, I'm a very ambitious young Python programmer that has bitten off far more than he can chew and is interested in other stuff as well, looking possibly for a programming job, but this is what I do. I find horrible things and I try and automate it. So yes, thank you.
Okay, now we've come to an interesting time. That's all the lightning talks, but don't run away just yet. We've got some fun to get through.